On this Honda CR-V, P0793 means the PCM may not be seeing the expected signal from the CVT intermediate shaft or drive pulley speed sensor circuit. The vehicle may have CVT shift or drivability complaints. The code can be intermittent, or it may return during a controlled road test. Treat this as an electrical diagnosis. Possible fault areas can include the sensor connector, the sensor circuit wiring, the power or ground side of the circuit, the signal line back to the PCM, or, after the circuit checks pass, the PCM software or PCM itself. The key point here is important. This code is caused by an electrical circuit problem, not by a mechanical problem inside the transmission. Start with the basic system checks, then verify the complaint. Turn the vehicle to on mode and clear the code with the HDS. Raise the vehicle on a lift, make sure it is securely supported, and let the front wheels rotate freely. Start the engine, turn VSA off with the VSA OFF button, then run the vehicle in D position or D mode. Keep vehicle speed over 19 mph 30 km/h for at least 30 seconds, then slow down and stop the wheels. Now check the HDS for pending or confirmed codes. If P0793 is back, the fault is duplicated and you move into circuit testing. If it does not come back, treat it as intermittent for now. Check for poor connections or loose terminals between the PCM and the CVT drive pulley speed sensor, and if captured operating data is available, try to reproduce those same conditions. With the failure duplicated, turn the vehicle OFF. Disconnect the CVT drive pulley speed sensor 3P connector, then turn the vehicle back to on mode. Measure voltage from terminal No. 1 of that sensor connector to body ground. You are looking for about 5V. If you have about 5V there, continue to the next voltage check. If you do not, leave this path and go to the NDRDD short to ground check later in the routine. Next, with the sensor connector still disconnected and the vehicle still in on mode, measure voltage from terminal No. 3 of the CVT drive pulley speed sensor connector to body ground. Again, the expected result is about 5V. If that voltage is present, go on to the sensor circuit check. If it is not present, repair and open in the VCC1 wire between the CVT drive pulley speed sensor and the PCM. Now measure between terminal No. 2 and terminal No. 3 at the disconnected CVT drive pulley speed sensor 3P connector with the vehicle in on mode. The expected reading is about 5V. If that reading is present, replace the CVT drive pulley speed sensor. If it is not present, repair and open in the SG1 wire between the CVT drive pulley speed sensor and the PCM. If the earlier terminal No. 1 voltage check did not show about 5V, turn the vehicle OFF. Jump the SCS line with the HDS and wait more than 1 minute. Disconnect PCM connector C, the 51P connector. With the CVT drive pulley speed sensor connector still disconnected, check continuity between terminal No. 1 of the sensor connector and body ground. If there is continuity, repair a short to body ground in the NDRDD wire between the sensor and the PCM. If there is no continuity, the NDRDD wire is not shorted, so continue to the open circuit check. For the open check, keep the vehicle OFF, the sensor connector disconnected and PCM connector C disconnected. Check continuity between terminal No. 1 of the CVT drive pulley speed sensor connector and terminal No. 33 of PCM connector C. If there is no continuity, repair and open in the NDRDD wire between the sensor and the PCM. If continuity is present, the NDRDD wire checks OK. At that point, update the PCM if it does not have the latest software, or substitute a known good PCM and recheck. If P0793 goes away after a PCM update, the troubleshooting is complete. If it goes away with a known good PCM substituted, replace the original PCM. After the repair path is completed, verify the repair by confirming P0793 stays gone under the same kind of operating conditions used to duplicate it. The practical takeaway is to prove the code first, then separate the circuit into signal, feed, ground, and PCM side checks before making the call. For more diagnostic training, visit stepdiagnostics.com.